Dear students, in this video lecture I am going to explain how to solve a numerical when a resultant force for a concurrent system is asked to find out. Let me tell you first the resultant of a concurrent force system in a space. Resultant of a concurrent force system in a space is obtained by finding the summation of components of each force with respect to x, y and z axis. The resultant is expressed as a vector. R bar is equals to Rx I cap plus Ry j cap plus Rz k cap. R bar is equals to, we can say that summation fx into I cap plus summation fy into j cap plus summation fz into k cap. The magnitude of the resultant force is expressed as under root of Rx square plus Ry square plus Rz square. It means under root of summation fx square plus summation fy square plus summation fz square. The direction cosine of the resultant force is defined as theta x equals to cos inverse of Rx upon R, theta y equals to cos inverse of Ry upon R and theta z equals to cos inverse of Rz upon R. Let's see the numerical on the resultant of a concurrent force system. Numerical is given as a tower is held in position by 3 cables. Determine position x, y for the cable DA so that resultant force exerted is directed from D to O. Refer the below figure. Also find the resultant of the given force system. To start the solution, first find out the coordinates of each point. As the points are given, origin O point, A, B, C and D. So you can see the coordinates I have defined in this table. As you find the coordinates, you will find out the components of each force in easiest manner. So see that when you find the coordinates of each point, then in that case you need to find out the parallel distances from the origin for a given axis. Now we can say that the given axis for this numerical is, this is x axis, this is y axis and vertical is z axis. With the observation, let us start to define the coordinates of origin. Origin is having x coordinate 0, y coordinate 0 and z coordinate 0. Then come to the point A. First of all, find out in which plane the A point is. It is in between positive y and positive x axis. Therefore, x and y coordinates will be defined, but the z coordinate will be 0. A is defined. Parallel distance to the x axis from the origin, you find it is given as unknown x. Parallel distance from y from the origin, you can find out for the A it is y, unknown y, and z coordinate will be 0. Come to the point B. B point is defined in plane negative x and positive y. Therefore, parallel distances we have to find from the origin for the point B. Parallel distance to the y-axis, it is from the origin, it is 4 meter and it is positive 4. Then parallel distance from origin to the point B is along the negative x side, it is defined as 6 meter negative. It is minus 6 and the y and the z component will be 0. C point, it is defined in between positive x and negative y axis, so the z coordinate will be 0. For this case of C point, x is positive, this x is given as 16 meter. Then for the point C, negative y distance is defined as minus 18 meter and z coordinate will be 0. D point is defined on the axis Z. Therefore, x coordinate is 0, y coordinate is 0, and y distance from the origin is defined as 24 meter. Above the origin, the distance for the D point is given, therefore it is positive 24. I hope you have clear how to find out the coordinates for a given force system. Let us see that in the question it says that resultant force exerted is directed from point D to O. It means that the system is concurrent at point D and the resultant for the entire system when the cables are attached at point D is passing from the point D. The resultant passing from point D towards the O, it means that a directional vector is given for the resultant force. A directional vector as a resultant is defined from D towards O. Therefore, its magnitude we can define the resultant as a vector in Cartesian coordinate system as Rx I cap plus Ry j cap plus Rz k cap. Resultant force for a given force system is defined from D to O. Therefore, we can say that vector is equals to force as a vector is equals to magnitude of the force into unit vector, and resultant is passing from D towards O, so we can say that the expression of this, the coordinates of O minus coordinates of D with using the unit vector equation as magnitude of the force into x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap upon under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. For this case, the coordinates of O minus coordinates of D, we can say that the coordinates of D as 1 and coordinates of O as 2. So with this case, the coordinates of 0 O minus D, it is 0 minus 0 I cap, 0 minus 0 j cap, and 0 minus 24 k cap. So with this case, we have got the equation as R bar is equals to minus R into k cap, which indicates that the direction of resultant force is downward towards the point O and it is acting along the Z axis. As the resultant is acting along the Z axis, it means that the component of resultant along the X and Y axis will be 0. Means Rx equals to 0 and Ry equals to 0. Now, at this condition, Rx means summation Fx and that becomes equals to 0. Ry, that means summation Fy, that become equals to 0. By taking the reference of this given data, we can say that the numerical we can proceed to find the unknown. Now you can see that at point D, the forces are acting in the cables from point D towards the C, from point D towards the A, from point D towards the B. The magnitude of dB is given as 800 Newton. dA is given as 400 Newton and the magnitude of DC is given as 600 Newton. With this case, we can solve the numerical by using the definition of a vector when a vector is passing from one point to another point. Then in that case, the vector is expressed as magnitude of the force into unit vector from point 1 to point 2. So we can see that the force vectors by using the coordinates. Now the vector TDA is expressed as magnitude of TDA into unit vector from D towards A. The coordinates of A minus coordinates of D I have defined in the equation x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap upon under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. By substituting the coordinates in this equation, coordinates A I have mentioned as 1, coordinates of D I have mentioned as 2, and with that I have found the equation for the vector TDA with the unknown xy coordinates. I have expressed the vector TDB and I have expressed the equation in the form of unit vectors ijk. I have defined the same by using the coordinates of DC from C towards D. I have expressed this equation, and now for this case I have used the condition as Rx equals to 0 by taking all the x coordinates, all the x components from the equation of these three forces. So now the equation I got as 400x upon under root of x square plus y square plus 576 minus 191.54 and 282 plus 282.35 equals to 0. By solving this, I got the equation as 400x upon under root of x square plus y square plus 576 equals to minus 90.81. The similar manner, I have used the equation Ry equals to 0. And I got the equation as 400y upon under root of x square plus y square plus 576 is equals to 189.95. I have given this as equation number 2. If you observe this, these two equations, if I take this x in the denominator and if I take this y in this denominator, so we can say that 400 upon under root of x square plus y square plus 576 is common in these two equations. So we can express this equation as 400 upon under root of x square plus y square plus 576 equals to minus 90.81 upon x is equals to 189.95 upon y. And with this two equation, I can express as the relation of y with x, and it is y equals to minus 2.092 x. Substituting this value of y in the equation number 1, and then I have defined the same value of x. Substituting in this equation number 3, I got the value of x as minus 6.41 and I got the value of y 13.4 meter. With this solution, we have found the coordinates which are asked to find out at a point A as x and y. The resultant of the given force system is directed along the z-axis, therefore summation of z I have made, and with that the answer comes as minus 15.29.8 Newton. Minus 1529.8 Newton, and it is directed along negative z direction. So with this manner, we have to solve a numerical when it is asked to find out any unknown data by using the concept of resultant of a concurrent force system. Thank you.